Okay, Jai Hind everyone. I am Achintya Pandey as assistant professor in IT department. Today I will explore the runtime polymorphism and virtual function in object-oriented system design. Okay, so we will see the virtual function and their role in runtime polymorphism using C++. So polymorphism is of two types. One is compile time polymorphism and second one is runtime polymorphism. So compile time polymorphism is achieved by using the concept of overloading, I mean function overloading and operator overloading, while the runtime polymorphism could be achieved by using the concept of virtual functions, or it is called function overriding. Okay, so let's see one by one. Okay, now C++ allow base class pointer to point to the derived class object. Okay, so it is the capability of base class pointer which could point the base class object as well as the derived class object, but vice versa is not true. If we make a pointer to a derived class and see we want to store the address of base class, that could not be possible, but base class pointer could point to derived class object also. Okay, for example, suppose this is a base class and we are going to create a pointer to base class. So this pointer, this P1 pointer, which is a pointer to a base class, they could store the address of derived class object also. Okay, so one thing is that, the important thing is that if we are going to access, say by using the base class pointer, so only the member which is derived from base class, they could only be accessed by using the pointer to derived class. I mean base class pointer. Okay, the member which is in derived class, I mean the core member, either it is variable or function, they cannot directly access by the pointer to base class. Okay, only the member which is inherited from the base class, they are going to, I mean access by the base class pointer. But we could by using the concept of virtual function, and it simply does in Java. Like, okay, so we could access, I mean even the core member of derived class by using pointer to base class. Okay, so see how. See with the example, here we have a base class B, okay, and a member function. So this just contains a single line of code which is going to print base. Now we have a derived class, derive, and this base class is going to publicly inherited B. So we have again a so class. Okay, so function. Similarly, here we have just created object B1. So B1.show will print simply B1.show will simply print the see, the function name is same. Okay, so and we have created base class object. So by using base class object, we can access invoke the function which is in the base class, that is base. So that's why the output will be base. Similarly, we could access say object of derived class D1. Okay, so by D1.show we could access, I mean the function which is in the derived class, and so the output will come as a derived. Now we have just created a pointer PB which is a base class pointer because we have assigned the address of base class object. Now if we say are going to invoke the show function pb.show, it will simply print the base, it will not print the derived class. Okay, but now if we store the address of derived class object here by using this line, we are just storing the address of derived class object, and we want to access show function. Okay, so only the base class function will going to invoke this one. Okay, not the derived class object. Okay, but what we want, suppose we want to execute the function to which this particular pointer is going to belong. See here, by writing this line, this particular pointer, that is base class pointer, is now pointing to the object of derived class, but the function which is a base class is going to invoke. Although both has same name, same I mean everything, I mean argument and all, but the function which is in base class is going to invoked. Now what we want? We want the function to which, I mean the pointer to which this particular derived class is going to object. So the function which is in derived class should be invoked. Then we would have to use the concept of virtual function. Okay, so this is some I mean point related to the this particular derived class or I mean base class pointer. So while it is permissible for a base class pointer to point to a derived object, the reverse is not true. Okay, we can perform, like we have seen that this is the not true. Okay, we cannot store the object of base class by using the derived class pointer. So we can perform a downcast with the help of a typecasting, but should use it with a caution. Okay, see here, this is a base class, this is a derived class which is going to access, I mean inherit the base class, and similarly a class XYZ having no relation with the base and derived class. Okay, so this is the object of base class pointer. This is the object, and this object I mean this is the object of derived class, and this particular pointer which is base class, they could store the address of derived class object too. Okay, similarly we have pointer to derived class and all. Okay, so we have just typecast, but this is invalid typecast, no okay, invalid casting, no compiler error, but may cause runtime error. Okay, this is, so actually now we are going to show how virtual functions are going to implement the runtime polymorphism. So we will see with the example. Okay, first what is virtual function? So a virtual function is a member function, okay, that is declared within a base class and redefined by a derived class. So this virtual this is called overriding. Okay, because virtual function is declared in a base class and it will be defined in the redefined, basically in the derived class. This is called overriding. So it implements the one interface multiple method philosophy that underlies polymorphism. Okay, the keyword virtual is used to designate a member function as a virtual. Okay, it supports runtime polymorphism with the help of base class pointer. So I mean runtime polymorphism with the help of base class pointer. So here we will see that how a base class pointer which now going to point the derived class objects, and they are going to access the even the core function core member of the derived class. Okay. Okay. So while defining a virtual function in a derived class, the function signature must match the original function present in the base class. So we call it overriding, not overloading. Okay, overloading means in overloading we just find the match. Okay, means there may be difference in say number of argument, type of argument. So depending on the match, a particular function invoked in function overloading. But in overriding, everything is same. I mean number of argument is same, function name is same, everything is same, but we want to execute the function or the member which the function which is in a derived class. Okay, I mean the pointer which point to which object, either derived class, then could access the derived class functions, and if pointing to the base class, then it will already access the function of the base class. Okay. Okay, so we call it overriding, not overloading. When a virtual function is redefined a derived class, the keyword virtual is not needed. Fine. but can be specified if the programmer wants. So, the virtuality of the member function contained along the inheritance chain. A class that contains a virtual function is referred to as a polymorphic class. So, let's elaborate. Just we are going to elaborate. I am going to elaborate the pointer to base class, and using the pointer to base class, we are going to point the derived class and the functions. Okay. So, this is a base a base class, and we have simply make this show function which is in base class as well as derived class, but now we simply make this virtual this show function as a virtual in base class. Now, this is a derived class. This simply going to inherit base class publicly. So, again we have a show function. The function name is same. Okay, and just a single line of code which prints say derived. Now, we have a base class object. By using base class object, we simply we are going to execute, I mean invoke the show function. So, this will print this particular this particular code will be executed. So, it will print base. Okay. Similarly, we have a derived class. Derived class d1 dot show will simply print the function which is in derived class. So, this output will come static binding. Now, we have created a pointer to a base class, that is PB, and it contains the address of base class object. Now, if you are going to invoke the show function using this base class pointer which is just pointing to the base class, so it will definitely show this it will definitely execute this particular code. So, the output comes base. Now, this is the main the highlighted point. This base class pointer PB is now going to store the address of derived class object, that is D1, because D1 is a derived class object, and this base class pointer is now pointing to derived class by assigning this particular assignment. Okay. Now, if now we are going to point this show function, so it will simply invoke the function of the derived class, the core function, the core member function of the derived class. It will not execute this base. Okay. So, this will print the this will invoke the code of this function in derived class. Suppose if we will not use this particular keyword virtual, then if we are going to access say this particular line, then it will again print the base. It will not print this one. Okay. So, just by writing virtual keyword, in a base class, we can redefine. We have redefined here so, and we are simply executing the function of the derived class. Okay. So, the meaning is that if we are if we have a base class pointer, and this base class pointer is now going to point which class, this particular class, okay. So, that particular member function of the class will be going to simply execute if and only if we have made that function virtual in a base class. Okay. So, this is what we are trying to achieve. Okay. So, runtime polymorphism is now going to, because we are simply assigning the pointer of which class? Derived class. So, that function we want to execute, the function of code derived class should execute. So, this could be done by simply writing the keyword virtual in base class. Okay. So, this is what. So, we can see. Okay. So, if we want to omit the body of a virtual function in a base class, we can use pure virtual function like this. We can simply assign 0. There is no definition. So, this becomes the pure virtual function. It makes a class abstract class. We cannot create any object of such classes. Okay. It forces derived class to override it, otherwise they become abstract too. Okay. So, we have pure virtual function. It helps to guarantee that a derived class will provide its own redefinition. We can still create a pointer to an abstract class, okay, because it is at the heart of runtime polymorphism. Okay, so when a virtual function is inherited, so is its virtual nature. Okay, we cannot we can continue to override virtual function along the inheritance hierarchy. Okay, so this is the I mean summary of virtual function and runtime polymorphism. It is not automatically activated in C++. We have to use virtual function and base class pointer to enforce and activate runtime polymorphism using C++. But in Java, runtime polymorphism is automatically present as all non-static method of a class are by default virtual in nature. We just need to use superclass reference to point to subclass object to achieve runtime polymorphism in Java. But in C++, we would have to simply write the virtual keyword. Okay. So early binding means compile time polymorphism, and late binding means runtime polymorphism, and that is going to achieve by the virtual function, and in early binding we simply achieve by function overloading or operator overloading. That's all about. Thank you.